So what's new in ER Studio version 19.0? Before we start, let's reiterate on our mission for the product. So ER Studio is an enterprise tool for data architects to design and document data assets. And we have data assets in many different forms, lots of different products. So we've got an ongoing mission to support more and more products. You'll see that with this version where we're now supporting Azure Synapse Analytics. Over time you're going to see us do more and more relational databases, NoSQL databases, and also file-based formats. So that's the core of what ER Studio does. The third part is to extend the capability of that team of data architects, and we want to be able to connect data architects with other teams and tools around the organization, namely data governance and data analytics. And the vision is to form one single connected company-wide data ecosystem. So to recap on the product structure, so we've got data architects on the left-hand side, the thick client tool that you guys have been using to build conceptual, logical, physical models, etc. We've got Team Server repository in the center where we store our models, and then Team Server Core, which is the web-based part of the tool. And that allows you to publish your models and people can collaborate and subscribe on those data models. Now, as well as that, in Team Server Core, we've got our business glossary and data catalog. So prior to version 19, both of those are quite simple elements within the tool. So this latest version, we've done a lot of work around that business glossary, and there's going to be a lot of ongoing work you're going to see around Team Server Core. It's an area we really want to develop and extend. So the overall mission is to bring together these three parts to the model. So left and right, information and data, as well as just modeling the data assets themselves, creating those physical models that you can see on the right in technical language. We also want to build a model of the information of the organization. And those are the two models on the left-hand side. Now, traditionally, we've used logical data models, entity relation diagrams to model information. So that's the tool of choice for our data architects to model the structure of information in business language. Now we've got new tribes within the organization. We've got our data governance tribe, and they center their understanding of the information of the organization around a business glossary. So within ER Studio right now, we have a business glossary. In the new version, we're really sort of extending the meta model of that glossary. So the mission is not only to provide a flat list of business terms, but to arrange those terms into a meaningful ontology, be able to see taxonomies of terms. So in this diagram here, we can see that company has different subtypes. Vendor and client. We might see different types of clients and see quite a tall taxonomical tree. So when our users are browsing for information, they can browse through a nice, easy to use mechanism through that taxonomy. They can then find information related to an object. So information related to a company, we've got company name, VAT number. So the relationship between company and those other objects is an attributal relationship. And then you can see between client and order, there's a more generic relationship relates to. So again, we want to allow our user, using business language in a very friendly environment, to be able to browse the ontology, looking for the information that they want. So there's really sort of two big questions that we have for this model. The first one is, what information is important to me? And that's done within the business glossary. Once you've found that piece of information, so let's say we're interested in credit rating, the next question is, where is that information? So we want to be able to see objects in the right-hand side and even perhaps the bottom in the logical models. Say, well, show me where credit rating is instantiated in our data models and our data asset. So the new version allows you both to ask that question, and there's also improvements to enable our data architects to be able to make the connection from business terms to data modeling objects. So in that overall data governance mission, we want to be able to classify all of our data assets against the business glossary. And most of that will come from human knowledge, and which human beings have the best and most intimate knowledge of the data assets, and that's the data architects. So we want to bring that classification ability, the mapping of business terms to data modeling assets, closer to the data architects. So here's a summary of the main features that we've added to version 19. I'll go through the summary and then we'll look at the details. So on the data architect side of things, as we were talking about with the business glossary, we're making that more available to data architects in the data architect product to be able to help with that classification of mapping business terms to data modeling assets. We've done a lot of work to the SQL Server platform. So we've got a brand new parser behind the scenes that understands all of the latest grammar of Microsoft SQL Server and Azure SQL DB. We've also provided support for more features of SQL Server. So we've got things like temporal tables, common table expressions on views, etc. We now provide core platform supports for Azure Synapse Analytics. So all the features that you would enjoy with SQL Server and Azure DB. So forward engineering to the database, reverse engineering from both a database and a SQL file, and also from compare merge we can generate alter scripts. The last item on the list there, MySQL uplift. So we provided a tolerance uplift to MySQL. What we mean by that is we've tested against the latest version of MySQL and just made sure that there's no issues, and if there are any issues, then fix them. So that's the data architect side of things. On Team Server, most of our improvements center around the business glossary. So first of all, we've extended the meta model. Basic meta model that we had originally, extended it so we can model advanced ontologies, including taxonomies and such like. We've also got mechanisms to be able to visualize those relationships in a nice business-friendly manner. And not only can we visualize the relationships between business terms themselves, but from the business term across to our data model. So we can ask and answer those two important questions. What data is important to us, and then where is that data? The last piece on the list there is business term harvesting. So we've got a lot of customers that are starting off a data governance initiative. So they maybe don't have a business glossary, but maybe they do have some really good logical data models. Now, a good logical data model has entities and attributes expressed in plain business language. It's understandable by business people. So there's tools we've provided to be able to point it to an entire logical model or a submodel or even an individual entity. And you can pick and choose which of those entities and attributes will form business terms. And the tool will then create or map to existing business terms with the same name, taking the definitions from the logical model. Not only will it do that, it'll also pull relationships between those newly created business terms based on the semantic relationships in the logical data model. So you can really kickstart a data governance initiative and seed that business glossary. So let's look in more detail at the new features of Team Server. So three areas we're going to look at: advanced ontology support, graphical visualization, and business terms harvesting. So let's start with the first one. So we've got some new relationships, and I mentioned these earlier on. The first big one is the red line there. So now we can namespace business terms into different glossaries. So for instance, I might have a business term called policy that is part of an insurance glossary. And I've got another business term called policy that's part of my internal operations glossary. And the two business terms called policy are fundamentally different and set into the context of the glossary. So that's the first big change. We then added a number of primary relationship types between business terms. So we've got is type of, so we can build taxonomies, attributal relationships. I might have one business term that's a concept and another one that's more an attribute, so employee and employee number, for instance. And we can also connect our business terms together to form synonyms and create synonym rings. The next thing, we've added a bit more detail about how one business term relates to another. So currently in the product, you can relate two business terms together with a very simple relationship. We can now add information about that relationship. Well, how does this business term relate to the other one? So the overall objective is to support the sort of semantics that we create in our logical data models, but provide it through the business glossary in the place where the wider business will contain their accepted, approved standards for information in a format that is friendly to all business users. So they're the main changes. So let's go and look at that in the product. Here in Team Server, here's my list of business terms, and you can see against each business term we've got the glossary that owns that particular term, so the term is part of the glossary. You can also relate terms to other glossaries. They might have some sort of looser relationship, but only one glossary can own the business term. So in my example, I'm going to search for a business term called party. So party is part of the business-wide glossary, and as usual I can see all the basic properties of the business term and confirm that this is the piece of information that I'm looking for. You'll notice over on the left hand side we've got our new taxonomical and ontological relationships. So party could have different subtypes. So here you can see that a party now has two subtypes of organisation and person, and this continuously decomposes to lower and lower levels. So two things here. The first is the taxonomical relationship between the terms, and the second here is this nice graphical visualization that allows us to view this. And some of these trees can get potentially very large, so we've got mechanisms in there to expand and contract. So I can drill down through my tree. So I'm interested in personal data, but I'm particularly interested in employees. So I can double click on employee, again see the definition. Yep, this is the information I'm looking for. And maybe now I'm interested in specific pieces of information about an employee. So I could go to my related tab and see that employee relates to departments. Department contains employees and is managed by an employee. So there's our relationship types. And we've also got a relationship from employee to employee skill matrix, and there's no further details around that. And I can see that in a list form. So when I'm creating these relationships, I've got a nice mechanism that allows me to assess the forward and reverse relationship. And it creates a meaningful sentence. I can even include multiplicity values in there. So again, we're really trying to sort of recreate the sort of semantics we can create in a logical data model. So now perhaps I'm interested in particular information about an employee. I'm perhaps interested in an attribute of an employee. So here I've got various different business terms that are related to an employee through the attributal relationship. I can see this either as a tree or a grouping. And in this case, I'm really interested in employee number. So again, I can double click on the business term, go and see employee number. This is the information I'm looking for. So that's the first question answered. What information am I interested in or is important to me? The second one is now, where is that information? So if I click on my related ER objects section here, I can see a breakdown. Now, employee number is a pretty common piece of information that's used in many different systems. So I've got many different projects containing data modeling assets that are instances of employee number. And I can see that through here. So my HR database, for instance. So I can expand this model and I can see that I'm present in my logical model and 4 different physical models. If I expand my logical model, then I can see that I've got a bunch of different entities that contains attributes, in this case employee number. And I can also go and see the physical models that contains this information. So I've got, in this particular physical model, I've got 5 different tables, each with a column called EMP NMB, which is an instance of employee number. And I can go and look at different projects. So we're going to have a look at our AdventureWorks projects. And I can see that I've got a bunch of different tables, and I'm using a column name employee ID, and similarly in the logical, I'm using employee ID. So this shows how the naming convention differs across different projects, but they're all instances of the piece of information employee number. We've also added the graphical element in when we're browsing our data models. So here, if I look at my logical model here, I go to my employee entity. Now, and we're familiar with this within the data architect tool, we've got our where used tab and our universal mappings. We've now got a graphical element in here. So this is showing me that, if I expand this to the maximum level of detail, so it's showing me that within the same model with these grey lines, my employee entity has been mapped to 4 different tables and the 4 physical models, each one called EMP. We've also got a universal mapping with this green line to the salmon coloured model over here. So within my corporate logical data model, my local employee entity we're saying is an instance of the corporate entity employee. So we can see all our universal mappings as well. So the next improvement is our business term harvesting component. So the idea here is to be able to create business glossary from traditional logical data models. So in practice, we would reverse engineer a physical model and we document it with a logical data model. And now many of our customers have been doing this for many years, and I've got some really good, rich logical data models, all expressed in good business language. So the opportunity here is, if we don't have a business glossary, or we want to enrich that business glossary with new terms, then we can harvest terms from that logical data model. So in this case here, we can see that we've got an entity company, and from that we could create a business term called company, and likewise we could create a business term called company name. So the harvesting capability allows you to point it to an entire model, or an individual submodel, or even an entity, and select from the entity and attributes which of those you want to create and map to the newly created or newly found business terms. Not only that, it'll add the ontological relationships between those terms. So we see that some customers who have been working with flat lists of business terms in their glossaries might want to go the next stage and connect those terms together to form that ontology, that goal that we're looking to achieve. So with our harvesting gadget, in this case, we'd run it on this model at the bottom. So company, do I have a business term called company? No, I don't. I'll create one. Do I have a business term called company name? No, I don't. I'll create one and map it to the attributes. Do I have a term called VAT number? Yes, I do. I found it over here. I will connect this attribute of this model to that existing business term. So the first step, it goes through and creates and maps, or maps to the existing terms. Now the next thing it does is to look at the relationships in the logical model. So we're trying to replicate the semantics in the logical model into our business glossary stroke ontology. So in this case, we'd see a relationship from company to client through the subtype relationship. So again, in our business model, we'd create an is-type of relationship between company and client and start to form that taxonomy that we've been looking at earlier on. Likewise, from company to company name, so the entity to the attribute. Both of these have appeared as business terms in our glossary, but we can now create an is-attribute relationship between those two terms. And the last one, from client to order, we have a relationship, and we can create a more general relates to relationship in our business glossary. Now remember, earlier on we can also store additional properties against that relationship. So if this relationship in the logical model had a name, had multiplicity, we'd carry that over to the relationship in the business glossary. So all in all, the objective is to be able to harvest the semantic knowledge of our information from these really good, rich, logical models that you guys have been creating, and to populate our overall business-friendly ontology. Just to see that in action, if I open a model, you notice that at the submodel level or an entity level, I've got this Harvest Terms button. So I can click Harvest Terms, and it gives me a breakdown of all of my entities and attributes. It allows me to select individual entities and attributes, or all of them. So I could just select one entity here and these attributes, and I can select which glossary I want to put them into, or I can create a new glossary. So there, I've created a new glossary. I can change the names of the resulting business terms. So here I may want to create a term called address line, and I can also see the definitions that have come from the entities and change those and put my own definitions in. And then when I run the gadget, it goes through and creates terms as we've just discussed and the relationships between them. And here it's now telling me that these terms have been successfully created, and gives me a nice hyperlink to the individual terms. And I should be able to see for address, attributes children, there's all those attributes that have come from the entity. And the last improvement that's worth mentioning is that Team Server, we know we can run on Oracle and Microsoft SQL Server databases, and we can run on SQL Server running on an Azure platform. Many of you are now moving to the cloud, so we can now run Team Server on Azure SQL DB. Okay, so let's look at what's new in Data Architect version 19. So we've been busy. There's a number of areas that we've made some really good improvements. So the first one is more around that business glossary work we've been doing in Team Server. So again, the objective is to allow our data architects to contribute their valuable knowledge about what data means, and allow them to classify their data modeling assets against the business terms. So really support the data governance initiative. So we're going to look at this inside Data Architect. So I've got a model here. I've checked it into the repository. So we can only map to business terms objects that have been checked into the repository. So here I've got an entity employee. So if I edit this entity, I can see that I've got a new tab here, Business Glossary. At the moment there's nothing mapped to it. If I click Add Term, it'll allow me to search through all the different glossaries in Team Server and search for the appropriate business terms. So it's already populated my search box with the name of the entity and given me any business terms with employee in the name. And I can click on the hyperlinked name and open up the objects in Team Server. This one I'm pretty sure this is the one that I want. Looks good to me, so I'm going to relate that. So this is the employee term in the Human Resources Glossary. And as soon as I apply that, then it'll apply it to the model inside Team Server. So if I move over to Team Server, I can see the entity in our model. And I go to the Related Terms tab. And if I refresh, and immediately it's related the term together. Likewise, if I go across back to the term itself and see related ER objects, it's now showing me the relationship in the graphical level. If I expand, and there it is, there's employee. We've also done lots of work around Microsoft SQL Server. So as I said earlier, we've built a brand new parser supporting all the latest grammars of SQL Server. We're also supporting now common table expressions in views. So let's go and have a look at that. So in my physical model here, now supporting SQL Server 2019, I've created a view here, view employee with skills. And inside the view, we've now got a new tab with CTE view. So through the reverse engineering process, it'll populate this out, so I can see the CTE columns, return columns, and the select statement for the CTE view, which builds out the correct DDL code for the table itself. We've also done a little work on indexes, so we can now apply some new types of indexes, filters and column store indexes. We've also got support for spatial indexes. Let's go and have a look at that. If I open up this table, in my indexes tab, in the options, I can see I've got new properties for filtered and column store. We've also got support for spatial, so a lot of the properties for spatial indexes we can set here. It'll obviously there's various rules built into it, so if you're creating spatial indexes, there has to be a geometry or a geography column in the index. We've also done work around compression, so we can set compression for indexes here as well. And likewise, against the table, we can now support compression properties. We also support temporal tables. So again, looking at the storage tab of an entity, we've got a new section which allows us to specify the versioning properties of the table. So if we set the history table, we can specify the name of the table that we want to create. So you can leave it as the default, which will allow SQL Server to create its own table. And when you reverse engineer, if there is already a system version table, a history table, it'll take the name of that and populate these properties. There's some nice little features in here as well. So if you're creating a history table, you can automatically create the period column. So there's a button here that'll then go and create the period end and period start columns. Then the last item on the list is extended properties. So again, we've got a new tab here, extended properties, and you can add your own properties. You can give value and a value description, and there are checkboxes, so when you generate the DDL out, you can opt to include the extended properties as well. So a lot of work we've done in SQL Server. We also provide now core platform support for Azure Synapse Analytics. So we now have core platform support for Azure Synapse. So there is in our drop down of available database types for native connection. So we've built a native connector to Azure for authentication. we can select either Azure Active Directory, and we can also use this for Azure SQL database as well, or direct SQL Server authentication. So put in a username and a password and the URL to the Synapse instance, and then we can connect and select the Azure Synapse instance. So there might also be Azure SQL DB instances on the same Azure server. It'll filter those out and just give you the Azure instances. So we can select that, decide which owner we want to filter by, choose which objects we want to bring in, and then we're away. We can select the tables and the other object types and start the import. Now, as Synapse doesn't have foreign key relationships between tables, the inference mechanisms might be useful, but it very much depends on how you've named the foreign keys and how you set up the indexes. So this is connecting to the Azure instance, and now is bringing back all the table metadata. And there it is. And there's our model. All the objects that we've requested have been reversed. So as its core platform support, you can reverse engineer directly from the Azure server. You can reverse engineer SQL scripts files. You can also forward engineer directly to Azure or to a DDL script file, which you can then deploy yourself. And as its core platform, you've got alter script generation from the compare merge toolset. So the last feature I want to show you is the new support for inheritance relationships in Postgres. So going across to ER Studio here. So this is our logical model, and you can see from employee to full-time employee and contractor, we've got a super subtype relationship. Now normally when we generate a physical model from this, you'll get the standard identifying relationships at the physical level, and then you can use the roll up and roll downs to combine them together into a single table or multiple tables. With Postgres, we've got the option to create a new type of relationship, and so a built-in inheritance relationship. So let me show you how that works. So if we generate a new physical model and select Postgres from our list, when we get to page 2 of our Generate Wizards, on the Tables tab, we've got a new property here. So how do you wish to resolve subtype relationships in this model? Either use the standard identifying relationship or use the new inheritance relationships. So let's see how that works. Okay, so it's generated our physical model for us. And you can see now we've got two different looking lines between our employee table and our subtypes. And if we open that up, we can see that we've got a new property here, inherits. If we go and look at the code that will be generated for this, we can see the implications of that new property. Here's my SQL preview. And if I scroll down to one of those subtype tables, we can see here, so full-time employee. And it's got this inherits keyword in here, so it's going to inherit from the employee table, inherit all the properties and the primary keys. Okay, so to summarize, we've made a lot of improvements to both Team Server and Data Architect. This release has been mainly around our ongoing mission to connect data architecture teams with data governance teams. So we've done a lot of work on the business glossary. We've extended the meta model so we can now model advanced ontologies with taxonomies in there. We've done a lot of work on graphical visualization, so to improve the user experience, help answer those really important data governance questions like what data is important to us and where is it? We've got the business term harvesting capability, so you can kickstart data governance initiatives by exploiting all of the valuable knowledge in your really good quality logical data models. On the Data Architect side, likewise, we've connected the users of Data Architect closer to the business glossary so that they can be mapping business terms to data modeling assets. SQL Server, lots of improvements there, brand new parser, supporting all the latest grammars, lots of new features. We've got core platform support for Azure, Synapse, and we've done an uplift on MySQL. And again, I think we showed the feature with Postgres on inheritance. So a really feature-packed release in version 19. Okay, so thanks for watching. You can get more information at our community, so community.idera.com. Alternatively, contact me directly. I'm the product manager, jamie.knowles@idera.com. Thanks for watching.